Okay, so now we're going to look at lines that intersect circles, and specifically we're going to talk about tangents and some properties of tangent lines that intersect circles. So first of all, the basic lines that intersect a circle are a chord, which is a segment whose endpoints lie on a circle. Okay, so the endpoints lie in a circle. You can see in the picture, you've got A and B as your endpoints, and they're on the circle. A secant is a line that intersects a circle at 2 points. So it's got to be a line. You can see that it has the arrows for it to be a line, line L here. So a segment versus a line, so we've got a chord versus a secant. And then your tangent is also a line in the same plane as your circle. It intersects your circle at 1 point, and that's important. It's only at 1 point that it intersects. So your tangent is again a line. It's got these arrows, and it only touches the circle 1 time. That's an important property of your tangent. And then you have your point of tangency, which I'm sure you can guess, but this is your point where your tangent line and circle meet or intersect. You can see it's just that singular point. It only touches that 1 time. There's some other things that we just like to know about circles, and that's these 2 types of circles, and this is multiple circles. So concentric circles are coplanar circles, which means they lie in the same plane with the same center. And you see these all the time. These are bullseyes. Here, if you hunt or you play darts, you've seen these before. We see a lot of concentric circles. Your eyes essentially could be, they're not really circular necessarily, but they still can be considered something that's similar to this. And then your tangent circles. These are 2 coplanar circles, so they lie in the same plane that intersect at 1 point. Okay, so they're tangent, so that word tangent means that they're going to intersect at that 1 point. And then here you have internally tangent circles, so they're just touching 1 time, and one's on inside of the other. And then you got external, so two circles that touch on the outside. Okay, and this is kind of how some of your wheels and things work, is in both of those different ways by your tangent circles. Okay, so we've got some examples to look at. So in the first example, we're identifying all of the words we were just using, and also ones that we've seen before. So any radii that we might have. So I see PR, I see PQ, and I see PU. A diameter going from one side to the other through the circle, I see RQ. For a chord, you can cut this one off here, ST, just the segment of that, so the segment that's part of the line. Also, we consider the diameter to be a chord as well. It's touching the circle at 2 points. Your secant is going to be ST, because it's got these arrows. And your tangent is going to be UV, and it's also got those arrows. So the notation here, you need proper notation that we learned at the beginning of the year, segments and lines. In the second example, we're looking for the length of each radius, the point of tangency, and then the tangent line. So I see that circle A has a radius of 4, and I'm just counting 1, 2, 3, 4 out from here. I know from my equations of circles that my radius is just going to go out in every direction. In B, I'm doing the same thing, 1, 2. See that my radius is 2. I see they're touching. These two are internally tangent. Okay, so the point we're looking at looks like 3, 0. And then the line, this line here that is tangent to both circles, is vertical. Remember we talked about that little trick, Hoy bucks. I've got a horizontal line, 0 slope, y equals, vertical line, undefined, x equals. So this is going to be x equals 3. Okay, and last thing, just a theorem about tangent lines to your circle. Okay, we've got if two segments are tangent to a circle from the same point, and that's the important part, then the segments are congruent. We're bringing this word back, which means that they're going to be equal to one another. Okay, so here we have AB and AC are tangent to the line P, so that means AB and AC are going to be congruent. Okay, you've got a couple ones to do for classwork for this.